The chapter 7 through 9 final review packet solutions. We are almost done with the year. Feels very good. You're going to start with some true-false questions. And to answer these, it's helpful to have your conjectures list available to you. So let's go ahead and get started. I'll go through the true-false fairly quickly. Are any two squares similar? Yes, they are. Because squares are the same shape, but not necessarily the same size. So similar means same shape, but it could be the same size, could not be. Formula for surface area, that would be false because it is 4. It's 4 pi r squared is the formula for the surface area of a sphere. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. That is true. That's the AA conjecture says that that's true. Well, if the edge of two similar prisms are in the ratio of A to B, and the surface areas are, surface area is A squared over B squared. This area is squared. Notice it says two similar prisms. That's the key word right there. Prisms are similar, then this is true. Parallel lines intercept congruent arcs on a circle. That is true from chapter 9 conjecture. The ratio circumference over diameter is the same for every circle. That is true. Why is that true? Well, circumference is 2 pi r or pi d, right? And the diameter is 2r or just d. You notice how that cancels, and you're left with pi. And so circumference over diameter is the same for every circle. The center of a circle lies on the perpendicular bisector of every chord on the circle. That is true. That's a conjecture from chapter 9. Kind of like one of the quiz questions, number 4, where you had that arc and you drew two perpendicular bisectors to find the center of that circle. So a tangent to a circle is perpendicular to the radius drawn at the point of tangency. That is true. That's again from chapter 9. And for any given central angle, the radian measure for the arc of that angle is the same for all circles. That is true because the radian measure is x over 360 times 2 pi r over r. So the arc length divided by the radius. So arc length divided by the radius. Okay, notice how the radius cancels. And so really the only thing it's dependent on is a central angle. So if the central angle is the same, the radian measure is the same. That's the central angle. Okay. So part B, let's see here. Two polygons are similar if and only if corresponding angles are congruent. So the corresponding angles are congruent and the corresponding sides are proportional. And as we go through these, make sure that you are trying them on your own before getting the answers. It's going to be crucial to your learning. If a line cuts two sides of a triangle proportionally, then it is parallel to the third side. So parallel to the third side. That's a conjecture from chapter 7. A triangle has an area of 12 centimeters squared. If the length of one side of the triangle is 6 centimeters, then the length of the altitude must be what? Well, area of a triangle is base times height divided by 2. We know that's going to be 12. And so the length of one side of the triangle is 6, so that's going to be your base. Since the altitude is that, so that would be 6h over 2 equals 12, which means 6h equals 24 divided by 6, and h equals 4. So 4 centimeters. If a circle has an area of 32 pi and then a 135-degree sector of that circle has area what? Well, 135 divided by 360 times the area will get you 12 pi. And that's going to be the area of that sector. All right. Angles inscribed in a semicircle are right angles. That's again from chapter 9. If a circle has circumference of 18 pi centimeters, then its area is what? Well, if the circumference is 18 pi, that means your diameter is 18, right? Because pi times diameter equals circumference. So, or your radius would be 9. So the area is pi 9 squared, or 81 pi. And of course, your area now is 6 centimeters squared. If a 90-degree arc of a circle has length 5 pi inches, then the radius of the circle would be what? Well, we know that is the same thing as 5 pi is the arc length, and it would be, that means that the circumference of the circle is equal to 4 times 5 pi, which equals 20 pi. And that means that pi d equals 20 pi. So d equals 20, which means the radius is 10 inches. All right, so 90 degrees is a fourth of a circle. So 90 over 360 equals 1/4. And so that's why you're going to multiply that by 4 times 5 pi. All right. Let's see. Again, if you have any questions on this, feel free to come in and talk to me during lunch. I'm more than happy to help. As we continue going, I'll just go through them step by step. Surface area of a cube with an edge length of 5 inches is what? Well, a cube, the key to know about a cube is that each side length's the same, right? So that's 5, 5, and 5. So each cube is made up of squares. And the area of each square is 25. Now there's going to be 6 squares in a cube. And that's going to be 25 times 6, which is equal to 150. And that's inches squared. And there we go. All right, now we're in part C. So now we're in a long response question. The final will consist of some multiple choice questions. And then it will consist of some, when I say long response, I just mean what you see in part C, where you have to show your work. And besides, give me the answer. Area of triangle ABC. Well, first of all, we know we have a 3, 4, 5 right triangle, or if you would prefer, you could do, let's call this, you could do Pythagorean theorem, and then you would get x equals 3. And so the area is going to be 1/2 base times height. If the base is 4, then the altitude is 3 to that base, which is equal to 6 and centimeters squared. About the area of the kite. Well, again, you could call this maybe x and then y. We need to find that length there in order to find the area of the kite. The kite, again, is d1 times d2 over 2. D1 is equal to 48 plus 48, which is 96. And then D2 is equal to x plus y. And so we need to figure out what that would be. So we have a right triangle, so we can do Pythagorean theorem, right? 48 squared plus x squared equals 60 squared. And when you solve that, x will end up being 36. And then we have 48 squared plus y squared equals 50. Solve for y, you're going to get 14. But you don't actually have to do Pythagorean theorem. If you notice that for the triangle 48, 36, 60 triangle, that's a 3, 4, 5 right triangle. Because it's 3 times 12, and then 4 times 12, and 5 times 12, right? That's 36, 48, and 60. 3, 4, 5 right triangle. So you can just use that to figure out what x is. As for y, that's a 7, 24, 25. Right? So that's a 3, 4, 5. The other one's a 7, 24, 25, which ends up being multiplied by 2, right? 14, 48, 50. So, or but if you prefer, you can just do Pythagorean theorem. That'll work just fine. And so that means that D2 is going to be 36 plus 14, which is equal to 50. And so your area then is going to be, let's see, 96 times 50 divided by 2, which is equal to 2,400. Okay, so 2,400 centimeters squared. Now, what if you forget the area of the kite, right? You'll have a few minutes of notes on the final, but you're not going to have, well, actually, I rephrase that. You may or may not. I haven't decided fully yet, but I'll tell you in class. The thing about the final is you may or may not have that equation. So what do you do if you don't have the equation for the kite? Well, I want you to notice that the kite is made up of two triangles. Two triangles. These two triangles, I'll highlight one in green, and I'll have the other in orange. Right? So all you really need to do is find the area of those two triangles, add them together. Now the area is 1/2 base times height. So the area of the orange is 1/2 times the base of 50 times the height of 48. And then the area of the green is 1/2 base times height. Now, if you add those together, you will still get 2,400. So you get the same thing. So whether or not you choose to do it with the orange and the green triangle or just with the equation for the kite, either one will give you the same answer and totally acceptable. All right, moving on. Now we're going to do the area of the trapezoid. Now again, what happens if you forget the formula for the area of the trapezoid? Well, if you recall, this is really the same thing as two triangles and a rectangle. So if you forget, you can just find the area of the two triangles, add them together, the area of the rectangle, add them together, and you get your trapezoid. But the formula is a little bit faster, which we'll use in this case. This length here is going to be 8, and then this length here is 5. And let's see, this is 12, so that would be 9. Now, how did I know that? Well, again, you can do Pythagorean theorem, or you can notice this is a 5, 12, 13 right triangle. And the other one is a 3, 4, 5, right? 3 times 3, 3 times 4, 3 times 5 is 9, 12, 15. And so those answers come like that. Now, if you forget, you can just do Pythagorean theorem, right? X squared plus 12 squared equals 15 squared, solve for x. Or x squared plus 12 squared plus 13 squared equals, so on and so forth. But the area of the trapezoid is 1/2 B1 plus B2 times the height. Right? So 1/2 B1 plus B2, well, B1 is 5 plus 8 plus 9. Oops. 5 plus 8 plus 9. That's going to make it 1322. B2 is going to be 8, and so that's going to be 22 plus 8 times the height, which is 12. And when you do the math there, you're going to get 180. And again, our units are inches squared. And again, if you were just to do the rectangle, 8 times 12, and then 1/2 5 times 12, and 1/2 9 times 12, you add the two triangles in the rectangle, you'd also get 180. So there you go. Area of the shaded region. All right, well, here we go. So this, we need to find the area of the circle, which is pi r squared. And then we need the area of the square. The area of the square is just 6 times 6, which is 36. And so then you do the area of the circle. So the total area, AT, equals the area of the circle minus the area of the square, right? So that's going to be something minus 36. So what's going to be the area of the square? Well, we need to find the radius here. So let's go ahead and do that. Find the radius. So that's going to be that length right here. Now, how am I going to do that? What do you think? How would you find the radius? Well, wait a minute here. What if you draw another radius right here? Since they're both radii, you have an isosceles triangle, and you know that this is a right angle. How do you know that? Well, there's a conjecture that says that the diagonals of a square are perpendicular. And also true, the diagonals of a rhombus are perpendicular. So from that, you can know that's going to be a right angle, which makes these 2 degree angles the same, right? They're the same. They have to add to 90. So those are both 45, 45, 90 triangle, right? Which means that each of these are going to be 6 over root 2. 6 over root 2. And so from there, we can determine what the radius would be. Right, that's one way of doing it. The other way of doing it, which I think is probably a little bit simpler, is you could also draw a diameter. And you know this is a right angle because it's a square. And this is 45, and this is 45. And this is 6, and this is 6, making the diameter 6 root 2. And so the radius would just be 6 root 2 divided by 2, which is equal to 3 root 2. But you're maybe wondering, wait, is 3 root 2 the same thing as 6 over root 2? I just said that that was the radius, right? Well, it turns out it is, because if you just multiply it by 1, this is the same thing as 1, you get 6 root 2 over root 2 times root 2, which is 2, which is the same thing you have up there. See? So that is a very simple way of doing it. So the radius is 3 root 2, and so that's going to equal pi 3 root 2 squared, and that's pi 3 squared times root 2 squared, which equals pi times 9 times 2, which is equal to 18 pi. And so I'll put that right here. So 18 pi minus 36 is your answer. Since it wants an exact answer because of the equal sign. If there was an approximate sign like that, then you would write it as a decimal. But if it has that, then that means leave it in terms of pi, and that's going to be your answer. Like so. Okay. Let's see. Number 5. So here we need the area of the shaded region is equal to 91 pi centimeters squared. So basically we need to find the area of the large circle and subtract it from the area of the small circle. And that's going to be the total area. Okay, well, so the area total is the area of the large. We'll just call it pi r squared minus pi little r squared. And that's going to equal 91 pi. Okay, so big R, the area of the large circle is 3 plus x. The area of the small circle is just 3. And I'll go back to black here. So that's going to mean that pi 3 plus x squared equals, oops, hold on. Minus pi 3 squared equals 91 pi. And I'm going to go back up here, a little bit more room. So that means that pi 3 plus x squared equals 100 pi. Now, how did I get 100 pi? What did I do? Are you following me? So 3 squared is 9, so minus 9 pi is the same thing. So what we need to do is add 9 pi to both sides. And 91 pi plus 9 pi gives 100 pi. Well, divide both sides by pi, and 3 plus x squared equals 100. Well, you could FOIL it out, but you don't really actually have to do that because we can just go, well, 3 plus x squared is the same thing as 10 squared because 10 squared is 100. And so that means that 3 plus x needs to be 10. So x would have to be 7. And that is the answer. So 7 centimeters is x. Next is 6, surface area. Well, to do surface area, we need to find the area of the top and bottom circle and then the area of the lateral curved face, which if you unfold it ends up being a rectangle. These both have a radius of 5, so that's going to be pi 5 squared plus pi 5 squared. And let's see here. I know that this side of the rectangle is going to be 12, but what about the other side of the rectangle? What's that going to be? What's that going to be? Well, that is the same as the distance all the way around the circle. Right? This distance around the circle is the same as the top of the rectangle. So that we know that the circumference is just 2 pi r. Oh, but we know the radius. The radius is 5, so 2 pi times 5, or 10 pi. And so the area of this one will be 10 pi times 12. So that's going to be 50 pi. It's 25 plus 25 is 50, plus 120 pi. That's 170 pi. Uh, 175 feet squared, or approximately equal to 534 feet squared. Okay. Let's see here. Next, we need to find the area of XYZ. Okay, well, we have an equilateral triangle here, which means all of the angles are congruent. So they're going to be 180 divided by 3 is 60. So each angle is 60. Right, so we have an equilateral triangle. And each angle is going to be 180 divided by 3, which is 60. So the area of that triangle is 1/2 base times height. Well, the base, has to be 12. No matter what side I pick to be the base, it's going to be 12. But what about the height? What's the height going to be? Well, let's go ahead and draw in an altitude. That's always going to be perpendicular. Oh, look at that. We have a conjecture that says that if you have an altitude of an equilateral or isosceles triangle, that these are both going to be 30 degrees. So we have a 30, 60, 90 right triangle. And so if this is 6, then this would be 6 root 3. So 6 root 3 would be your height. And that's going to be the same thing as 6 times 6 root 3, 36 root 3. So 36 root 3 centimeters squared, or that's going to be approximately 62.4 centimeters squared. Okay. Next is surface area is given, and x equals what? Well, let's see. We have 6 faces here. We have 4 by 9, that's right, that's the top and the bottom. And that's going to be 4 times 9 times 2, right? There's 2 of them. We have a left and right. And that is going to be equal to, let's see, x and 4. We have 2 of those. So that's 4 times x times 2. Then I have a front and back. And that's going to be equal to, hold on, I can do a little bit better than that. 9 and x. That's times 2. So that's going to be 9 times x times 2. Okay. So that's surface area. And we know that that is going to be equal to 228. So 4 times 9 is 36, times 2 is 72, plus 8x plus 18x is going to be equal to 228. So that's 72 plus, let's see here, 26x equals 228. And if you subtract 72 from both sides, 26x will equal, let's see here, 228 minus 72 is 156. All right, so now what are you going to do to solve for x? Divide both sides by 26. X will be 6. 6 inches. Okay. Number 9, area of the shaded region. Now, even though this is in the 7 through 9, this was actually covered in 10.4, right? So this would be section 10.4. All right, so again, let's see here. We define the area of the kite and then subtract it from the sector area. So the area of the kite minus the area of the sector equals the total area. So the area of the kite is going to be equal to what? Let's go ahead and draw in a diagonal. Hold on. It's a different color here. We have that diagonal right here. Let's see. Well, these are both right angles because the radii is perpendicular to the tangent, and you can assume those are tangents. These angles here are both 30. It's going to bisect that angle. Let's see. And then, how do you know it's going to bisect the angle, right? Well, because these are both radii, and these are the same by another conjecture, and so this is a kite. And you know that the diagonal is going to bisect those angles of a kite. And that's going to make this 60. So you have a 30, 60, 90 triangle. And so if that's 12 root 3, this is going to be 12 and 12. And so to find the area of the kite, what I would do is just find the area of each triangle separately. So I would go 1/2 times 12 times 12 root 3 plus 1/2 times 12 times 12 root 3, right? I would find the area of each of the two triangles and add them together to get the area of the kite. And so the next thing is we need the area of the sector. And first you need to find the area of the circle. That's pi r squared. So the question is, with a sector, what fraction of the circle are we trying to find the area of? Well, the central angle is 60 degrees. And so the fraction is going to be the central angle divided by the measure of the whole circle, which is 360. And so that's the same thing as 1/6 of the circle. And this is going to be 12 squared times root 3 squared. And that's 1/6 pi times 144 times 3. And when you multiply that out, we will get 72 pi. And so the areas, and I didn't finish the other one here. When you multiply this out, you're going to get 144 root 3. And so now our total area is going to be the area of the kite minus the area of the sector. That's going to be your total area. So let's see what we get. 144 root 3 minus 72 pi. That's about 23.2. And units are centimeters squared. Whew. Wow, a lot of problems. All right. I guess just a few more and we're done. So number 10 comes from what chapter? Well, chapter 7 with proportionality, similarity. So because these are parallel to the sides of the triangle, it's going to divide each piece proportionally. That's going to mean that, let's see, that y divided by 9 is going to be the same as 12 plus 24 divided by 27. In other words, y divided by 9 equals 36 over 27. And so when you solve it out, cross multiply, y ends up being 12. What about x? What proportion could you set up for x? Well, we could say that x over 24 equals y over 9, but we know that y is 12. So that will give us that. And then we can cross multiply. And x will equal 12 times 24 over 9. That will be 18. There's many different ways to do this. You could also do, let's see, x over 24 equals like 27 minus x over 12 would also work. So then you could solve for x first, then solve for y. But the key is proportionality, right? So if you have these here, these two, if you divide them by each other, will be the same as this piece divided by this piece. So it divides them proportionally. One way you could think about it too is these triangles here are all going to be similar, right? So if you look at this triangle here, and this side is 27 and this side is 36, and then you draw this other larger triangle, this side here is 36 plus y, and this side here is 27 plus 9, which is 36. Then all we have to do is set up a proportion, and you can also solve for y that way. So 27 divided by 36 equals 36 divided by 36 plus y, and you could solve it that way. So there's many different ways to do these problems. Okay, let's do number 11 here. Notice there's an approximate sign there, so we are just going to find an approximate answer here. Well, for this one, we know that x divided by 30 is going to be equal to what? Well, this will be 24. What are we going to put on top? How are we going to write this length right here? Well, we're going to use the 20 for sure. And if the top is 20, then this would be 20 minus x. So I'll put that right there. And then let's go ahead and cross multiply. And so 24x will equal distributive property 600 minus 30x. Add 30x to both sides, and 54x will equal 600. Divide both sides by 54, and x will be approximately 11.11111. Keep repeating, so let's run it to 11.1. Okay. Number 12, find the exact length of GH. So when it asks for length, it's referring to a distance, not a degree measure. So the actual length of GH, that's the length of GH is going to be the central angle divided by 360 times the distance around the entire circle, which is 2 pi r. 2 pi times 5. So 72 divided by 360 times 10 pi. And when you multiply that out, you will get 2 pi. Okay. Let's go ahead and do 13. Last problem. Well, let me give you the answers. First of all, P. Well, a radii and a tangent are perpendicular, so P is just 90 degrees. Q, well, this is also 90. And we know that the angles of a triangle add to 180, so 180 minus 90 minus 35, and that's going to be 55. So that's what this is. And then with R, well, if this is 55, this is 55, and because of vertical angles, that's going to be 110, and so that would be 180 minus 110 divided by 2, which is 35, because these are both radii, making it isosceles. And so that's going to be 35 degrees. And then S, let's see, well, these are congruent because point outside to the tangent is the same on either one. So that's also 11 centimeters. Put the degree sign here. Okay. Well, that concludes the chapter 7 through 9 final review packet.